In this lecture, we're going to talk about using R for data science. And to this end, we will cover such topics as exploration data with visualization and summary statistics, regression analysis, and then we will conclude with introduction to Monte Carlo simulations with, I think that with 2 or 3 examples. Yeah, and those topics will be covered in this lecture too. Let's do a very quick helicopter tour of what we learned before. Yeah, so R allows us to communicate with its kernel using programming language, but also it allows us to communicate with the computer. For instance, here we get wt, this is get working directory, and if we save some objects, some results, we want to save not in the memory of R, but in the memory of in the storage of our computer, then we may want to communicate with the computer. Yeah? With ls, it provides existing objects in the memory of R. If, for instance, we create vector x, yeah, and we type ls once again, then we will have new object inside the memory of R. On the other hand, there is command system that allows us to use to run some system command of the operating system. Yeah, and if we type exactly the same thing as exactly the same command, but in quotation marks, we will get different result, because now it will be the content of our working directory. Yeah, so we discussed this before, yeah, but it's good to remember. R has a super powerful plotting engine, yeah, and we can only to illustrate this, to illustrate the most basic plot. Let's generate vector of x's. This is sequence from 1 to 20, length out 100. Yeah, so I generate 100 points, and now I create x, some relationship between x and y. Yeah, so I create quadratic relationship and I introduce some noise. Yeah, and here, if I introduce some noise, this is normal. This is a normal noise, noise from normal distribution. Yeah, and with standard deviation 1 and mean 0. Yeah, and if I want the default argument that I provide is number of random numbers that we will generate. Yeah, so if I want to generate 12 random numbers, yeah, I type rnorm 12. Yeah, but in our case, we want to add this noise to 100 elements that we observe. Yeah, because here we generate this artificial relationship. Yeah, and we should type this. Yeah, and now if we want to plot how y depends on x, we can do it in 2 ways. Yeah, the first way is that we type plot x comma y, and the first argument is the variable on x-axis, while the second argument is the variable on y-axis. Alternatively, we will get the same result if we type y tilde x. Yeah, and the result is exactly the same, but here we use this notation of formulas. Yeah, this formula tells us that y depends on X. Yeah, and those formulas are very useful in building regression models or some, in general, statistical models, and we will get back to this notation soon. R has 3 or actually 4 classes of objects. Yeah, that and depending on classes of those objects, we can do different operations on our of elements of those objects. Yeah, and here the first class are numerical variables. Yeah, and here we can make some arithmetic operations on those objects, on those vectors. Another class are strings. And today is Wednesday. Yeah. And now, yeah, this is vector. This is different vector. Now we cannot make arithmetic operations. Yeah, and so we can use we can conduct different operations on different classes. Yeah, and so we have numerical objects, strings, and also logical values, just like here. Yeah, and also, yeah, we have to remember about that. All elements of a given vector or matrix must be of the same class. Yeah, so if we type something like this, then true will be converted to 1. Yeah, because all elements must be of the same class. If we want to refer to some elements of our matrices, we use square brackets. Yeah, and yeah, here we refer to only one element. If we want to refer to several elements, we have to remember that this vector of indices yeah, must be written with C. Yeah, and this is it. Also, we can change the length of our vector. Yeah, and suppose that we want to add additional element to our vector. Yeah, that now this vector is of length 5, and we want to add additional element. We can do it by this. Yeah, and now we will have new element. Yeah. Alternatively, we can use if we want to add to this element, let's say the seventh element which is equal to 20. Alternatively, we can do it this way: that we take our old vector and we concatenate this with this. Yeah, and then we assign this output to our vector. Yeah. That being said, I wouldn't say that it's a very good programming practice, because this operation, this and this operation involve changing the size of our object. Yeah. So in the background, what R does is that it destroys one object and creates another one. Yeah, and it takes some time and some additional memory, which is not from time to time it is necessary to do it this way. But if, on the other hand, we know that our object will be on the length 100, it's better to first predefine a vector of empty objects, yeah, of zeros, and then only to make those changes to elements that we know what's the value. Yeah. So this is so if we know, if before running the code we know what's the dimension of our objects, it's better to predefine this and to keep this, not to change it. But again, from time to time, we will have to do it. Yeah, but we have to limit this to minimum. Now let's talk about factors. Yeah, before I mentioned this class of elements, yeah, but I wasn't very explicit between differences between factors and strings. Yeah, so the only thing that I mentioned is that factors are much more efficient in using storage use. Yeah, but from the perspective of users, also there are some important differences. Yeah, so let's talk about those differences. Let's create a vector of, let's say, 50 individuals. Yeah. Female 30. Yeah. We have gender. Yeah. And sorry. And now there is a command summary. Command summary works differently for different classes and different data structures. Yeah, and if we type summary, our old vector, let's create this. Yeah, here this is numerical vector of numerical values. Yeah, so it provides some summary statistics. Yeah, if we type summary gender, because this is a vector of characters, of strings, it provides only that, yeah, the length of this vector, yeah, and class. Yeah, and now if we do the same thing but for class, which is factor, and we factorize strings by command factor, what we will get? This looks almost the same. Notice that there are no quotation marks anymore here, and at the bottom there is information about levels, yeah, about all unique values that are defined for this data structure. Yeah, and now if we type summary gender for new factorized vector, yeah, it's something different now. Now it counted this as two factors, and summary gender summarizes how many females and male individuals are in our factor vector. Actually, a command summary is a wrapper. A wrapper in this sense that it calls another function depending on class of object that we provide as an input. Yeah, and for instance, here we have summary gender. Yeah, and exactly the same result we will get if we write table. Yeah, and table is it's a command that it is recommended to use only with factors, yeah, not with numerical variables, yeah, because if we have many unique values, our table will be very, very long. Yeah, and this is it. Yeah, and now suppose that we have another variable. Let's say that we have another 50 people. So here I created this manually in a deterministic way. Here I randomly sample. Yeah, we have false because I want to sample 50 elements from a vector of, here I forgot to mention this, for a vector with only 2 elements, so I have to be explicitly, I have to write replace equal to true. Yeah, that dark and blonde can be repeated. Yeah, and we have now two vectors of the same length, and if I type, it will be exactly just like with gender, quite similar, and yeah, it's balanced because I didn't provide any probabilities. Yeah, so by default, all probabilities of all types of all elements is the same. Yeah, so that's the reason why we have 25 elements. Yeah, and we can use table to study the relationship between one variable and another variable in this way. So if I provide 2 input arguments, table, gender, comma, hair, we'll get this matrix with information about all female blonde, female dark hair, male blonde, and male dark individuals. Yeah, and yeah, this is it. Yeah, also there is function prop table that as an input, this is important, that as an input it takes the output of table. Yeah, and what it does is that it expresses everything in relative terms. Yeah, and here this will work in equivalent way. Yeah, and to be very honest, exactly the same result can be obtained if we divide by all elements of table, we divide by number of observations. Yeah, here I can provide length hair, length gender, and it will be exactly the same. Yeah. Now let's talk about vector and matrices. Yeah, here let's create this vector. Yeah, and vectors have attribute length. Yeah, and it provides us number of elements. Yeah, at the same time, vectors don't have attribute dim. Yeah, so here we have null. Yeah, it's not defined. Yeah, and dimension is are those attributes typical for matrices and arrays. Yeah, and how to create matrix? So just like we discussed this before, this is our input data. Yeah, taken from the vector. The length of this vector is 16, yeah, and if we provide ncol equal to 2, as a result, it will provide matrix with 8 rows and 2 columns. Why 8 rows? Yeah, because there are 16 elements. Yeah, here we have matrix X. Again, I would like to remind here that if we don't provide argument by row, this data input is entered by columns. Yeah, and this is matrix X, and right now, yeah, it provides our dimension 8 times 2. If we want to combine 2 vectors into one larger vector, it's enough to use C, concatenate. Yeah, we can also provide some numbers, yeah, and here, yeah, this additional number will be added, yeah. We can combine vectors not only to create longer vectors, but also we can combine vectors to create matrices, yeah. And there are two commands, yeah. The first command is cbind, which stands for column bind, yeah, and this takes those our columns, yeah, and it put next to each other, yeah. This is cbind, yeah. And alternatively, there is rbind, row bind, yeah, and here those two vectors are put in such a way, yeah, that they're stacked by rows, yeah. And matrix 2. rbind and cbind works with matrices as well, yes. So if we have matrix 2, let's call it matrix 1, we have this matrix 1, and we can, in particular, we can cbind vec 1, so we can column bind with vectors, but also with matrices, yeah. And the same thing is about matrix 1 and matrix 1, yeah. So here we will have matrix of dimension 16, yeah, because this matrix was of the dimension, wait a moment, it was of dimension 8, if I recall correctly. 16 times 2, yes, 16 times 2, yeah. And if we bind those two matrices by rows, it will be 32 times 2, yeah. Okay. What is important to remember with cbind and rbind is that dimensions of combined objects must be compatible, yeah. And if we use cbind, for cbind, objects must have the same number of rows, yeah. So let's take a look at this matrix 120 rows 10. This is first matrix, second matrix, and let's create the third matrix, which has one additional row, yeah. And cbind matrix 1, matrix 2, yeah, it works. I don't know why it didn't work before, yeah, but here, so we have the same number of rows, yeah, so we are able to combine those two matrices, yeah. But also notice that number of columns of matrix 1 and matrix 2 are different, yeah. So it's possible to have different number of columns, but if we use cbind, the only thing that must be consistent is the number of rows, yeah. Because now, if we type matrix 1 and matrix 3, hopefully we will get an error message. Yes, error message, yeah. And the same thing, similar thing, can be applied to rbind, yeah. So right now, if we create this matrix with, let's say, 2 columns here also with 2 columns, and with 3 columns. So here should be this way. Yeah. Okay. This is our matrix 1, matrix 2, matrix 2. Okay, sorry. This is our matrix 2. This is matrix 3. Yeah. So now, if we type rbind matrix 2, those 2 matrices have exactly the same number of columns, and it works. It works, yeah, and the dimension of this is 25, which is a sum of rows of matrix 1 and matrix 2. Yeah. On the other hand, if we type, if we type this, yeah, we get error message just like with cbind. Yeah, so that was a very quick summary of what I taught in the previous lecture, yeah, and in the next part we're going to talk about plotting functions, and also I will introduce you to the world of Monte Carlo simulations. Yeah, so see you soon.